What is this, Lady Ada?
Hey, everybody, and welcome to our Hangout on Air. It's me, Lady Ada. We're here at the Adafruit Factory. I'm Miss Lady Ada. This is Mr. Lady Ada. We're a couple. But today is your day to shine. You're going to show us your projects. This is the show and tell. This is when you, the viewer, show up with your webcam and your phone and tell us what you're working on, what you're hacking on, what you're making. We're here till 7:50. We're going to call on people in the order we see them. Please take 2 minutes to show off your project so we can get to everybody, and then we'll get out of here and go on to Ask Engineers. So let's kick it off with Tony D.
Tony D, what you spinning?
Hey, yeah, so I'm on a spinner kick, and this is a real fidget spinner, not the digital one, although look in the learning system and you can see a guide that I did on how to create a digital version of the fidget spinner. But I saw a project with the microbit where someone hooked up a little beam break sensor and they used it to figure out what's the speed that a real fidget spinner is spinning at. And I kind of wondered, could I do the same thing with a circuit playground board? Because we have a light sensor and we have a bunch of lights on it. And so I thought, well, what if you just reflect a bunch of light up and then measure the light sensor and hopefully detect some of the reflections coming back and then be able to read that signal. And I'll do a screen share real fast just to show you. I don't have like a finished example working yet, but I'm working on that. And so let's see, do you see my screen?
Yeah.
Okay, cool. So you're looking at, this is just an Arduino sketch. It's just sampling the light sensor as fast as possible and just outputting it to the serial plotter. And so you get this kind of sine wave pattern. I think that's just, you know, a little bit of variation from like the LED lights that are gonna emit a certain frequency. But I'm gonna spin my spinner and I'm holding it over the light sensor, and notice how the signal changes quite a bit. So you get these higher peaks, and it's there's definitely some frequency to it that I can potentially detect. And so that's gonna be the trick to it. And I'll just show you real fast. Here's some screenshots. So this is kind of the steady state signal, and this is the signal when the spinner is spinning on top of it. So my challenge now is to figure out, you know, write some code that can detect the difference from the left side, the steady state, versus the right side when something's spinning, and then also measure what is this period between the peaks here. And I have an idea on how I'm gonna do that, because if you look right here, the magnitude, the difference from the low and the high points is actually pretty small in this signal. The Arduino serial plotter kind of hides that difference. It's trying to auto scale. Whereas right here, the magnitude is way bigger. So, you know, you go from a low value of like 100 or 200 something all the way up to almost 1,000. So I think if I look for a large magnitude signal like that and then do some frequency detection, I'll be able to figure out, you know, is your spinner spinning at like 300 revolutions a minute or something like that. So that'll be kind of the challenge that I'm going to work on next for this.
Okay, cool.
Cool, yeah. Let's see. How do I get out of here?
This looks great. I love science, math, and fidget spinners. Okay, next up, Noe and Pedro.
Hey guys, what's up everybody? So over the weekend, I do my usual browsing thingiverse and things, and I found this amazing model that I figured I gotta print this. This is a replica of the Guardian, the bad guys in the new Zelda video game Breath of the Wild. So this is fully articulating. His head moves and his little joints here move as well. This was not designed by me. This was designed by Steve on Thingiverse, and he designed it because his son wanted it. So I figured this is really cool. Maybe I can add some LEDs to it. So I kind of added these LEDs to it. So these little segments are not print in place, but this is print in place. And all these little segments kind of remind me of like threading like needle and popcorn. Remember when you make like popcorn necklaces? Yeah. So the wires are all routed through there, and there's just a regular 3mm LED. I drilled out some holes in the bottom of that because I just didn't feel like modifying the CAD. So it's sort of a little hack job. And then I have them all routed here into a little quarter-sized Permaproto breadboard, and then just a little JST adapter on it. So this is really fun. Again, it was just like a weekend project, more of a prototype proof of concept. So I figured I'd document it. So I put a guide together if you guys want to check that out. And I had fun putting together video for it, which is a lot of fun. And that's kind of it. I think it's a nice sort of thing. I hope people get inspired if they're new to electronics. Just wire up some LEDs over the weekend. I have a lot of fun.
Yeah, keep it easy. All right.
That's neat. And we'll be playing the video tonight.
Awesome. Thank you.
Okay.
Thank you. All right, next up, JP.
Guys, how you doing?
Hey.
Excellent.
Woohoo, awesome. So I have a new update to a guide for my mystery box Freefall Deck, which is a guide I put up a little while ago. So in Learning System, I added a page to take the mystery box Freefall Deck, which has a Circuit Playground inside and the original one, and now I've updated it for Circuit Playground Express using MakeCode. I'm kind of on a MakeCode kick of taking Circuit Playground projects and seeing if I can redo the coding instead of in Arduino over in the MakeCode interface. So this one has a freefall measurement. So when I drop the card deck, does a little SOS in Morse code. Inside, I just have a small LiPo on a Circuit Playground Express. And I'll switch over to screen share real quick and show you this is what the code looks like when you do the MakeCode version of it. So all I do is establish in the guide, I kind of talk a little bit about how variables work and why you use them. So at the start, I have variables that are how International Morse code is defined when it's in audio. So there's a pitch that's usually between 600 and 800 hertz. Then there's the length of a dot, which is around 200 milliseconds. And then everything else is relative to that. So I show that a dash is just 3 times a dot. A gap is the same as a dot. In between letters, it's 3 times a dot. And in between words, it's 7 times a dot. So that we establish at the start in the MakeCode. And then this is kind of brute force. I didn't do any kind of sexy routine or anything like that. This is just straight up bringing in your a little pause at the beginning. And then from there on out, we can have this play tone at pitch, which is this pitch I established up here, for a certain length of time. And so if I pick this, I can do a dash, a dot, a gap, inner letter, inner word, or the pitch variable is there. So this is what spells out SOS here. So you could kind of construct any message that you want, just going through with the graphical MakeCode. So that, get out a screen share here.
You're already out. We see you.
I'm out. Was I ever in?
Yeah, yeah.
Unless you have
You were just really fast at
unless your wallpaper is a picture of you. Then I'm fine with that. I mean, that's what my wallpaper is.
John Park. I always thought that was weird. Why do you have John Park as your wallpaper?
It's been like that for like 7 years too, so it all makes sense now.
So what's neat about this is that you wrote the original code in Arduino, but now you're writing it in MakeCode, and I think like what we found is it's easier to get started with MakeCode, but maybe it's not, if you want to have a very complicated program, you'd want to move to the JavaScript, not the blocks. But the blocks are really easy.
Blocks are usually a good way to get started. Yeah, and someone asked me about this recently, and I think that has often been this stumbling point for some people who come from programming, and then they see these graphical UIs. They say, well, but it can't do this, or this is a pain. And I think that that's absolutely the case, and that's the moment when you decide to go over to JavaScript, you go over to Arduino, you go over to Python. And it's cool that we have a lot of options now. But I think in a lot of ways it's fun to start out visually, because sometimes I just flowchart things before I start programming in code, just to kind of in pseudocode or even just drawing stuff to see what am I trying to do here. And these UIs actually kind of force you to do that, because you do have that graphical UI, so you can lay out what your logic is going to be and then make the particulars work. And it's really cool that you can simulate it inside the browser with that little simulator instead of uploading every time. It's actually faster to iterate that way for this type of project than in Arduino, where you're going to try something and then compile and upload, which takes 10 seconds, 30 seconds, whatever it is. And here it's instantly playing on that little simulator, which is kind of cool.
If you add up all the time it just takes to compile something, just generally speaking, all forms of microcontrollers and programming, and you get all that time back in your life, you have like years.
It's only 30 seconds, but it's 30 seconds every time. And also, like, if the upload doesn't work, you have to retry it.
It's years.
It is this, like, you get out of it, right? You leave that flow state.
So we're saving your life.
You've saved lives today. So
yeah.
Okay.
No need for the SOS.
Okay.
All right.
Thank you for the update.
Next up, Erin. Erin. Beep, beep, beep.
There we go. Hi.
Hey.
I'm here to show off my new unicorn project. I made a hat, which is just one of these animal hoodie hats, and I added a light of horn because you have to do that. But then the cool thing about this project is it's got a couple of servos inside the ears, so the ears can move back and forth, which is really pretty fun. It's making a lot of little kids happy so far whenever I wear it out. The horn is pretty cool. It's actually made out of light pipe. It is a 3D printed base that just has the light pipe sticking through, and then I just twisted a light pipe together. So it's really flexible and really cool, and it kind of looks like it's made out of glass. But then the cool thing is that each of the pieces of light pipe is a different color, because each one is on a different Neopixel. So it's a little hard to see on the video, but like the color is just, I mean, it's just.
Oh yeah, it's like a swirl of different colors. It's like a candy cane.
Yeah, it's a lot of fun. And then there's just a little joystick inside the pocket that comes at the bottom of this. It's one of these hats that has pockets that go down for your hands. And inside of one of the pockets is a little joystick where you just push it left and right, and that changes the orientation of the ears. So it's pretty fun. I've made up a guide for this. It's going to be live probably in the next couple of days, but I'm just super excited about it. So I'm not sure.
Dude, light pipes are always the best. Okay, thanks.
Outstanding.
Magical.
Next up, Orlando.
Hi.
Hey.
I don't know if I ever showed the update to this, but I finally got it so that it switches back and forth between face and game, or with a little toggle switch. And it has a couple different facial expressions. Did I show the facial expressions before?
One could say this is your game face mode.
Oh yeah, now I remember. I have that. Oh, I got it. Yeah, no, I didn't show the expression. There's very different, a tons of different smiley faces. I'm usually always in a good mood. Then there's a sad, because everyone is sad sometimes. And then there's the angry.
Wow, that's great.
You never have to use that one. And then there's the meh. Yeah, you're not just kind of really feeling it.
Can you make a snowflake one? I was called a snowflake today on the internet.
Okay, cool. I'll look into that. I'm not sure if that's
Definitely.
the
I
positive.
don't know what it's going to look like, but
Maybe you can have like a little star, like a star.
yeah.
Sometimes you feel like a star.
And then, of course, you switch to the game. And I'm actually updating it so that there's a little heart rate monitor here because I'm a biomedical engineer. I have to do something BME related. So this green light's actually going to transition to a heart rate monitor. And so they'll put their finger here and then my heart goes up. So I think it'd be kind of cool.
Yeah, that's cool.
Outstanding. Well, any badge you want, just email support@adafruit.com. And, at Adafruit every week, we have State of the Fruit. It's a half an hour at the end of the week. And we all go over stats and everything. At the end, we do hug reports instead of bug reports. And I might start doing that on Show and Tell. But hug report for Orlando, who's helping to keep open source free as in freedom. Thank you for your help with some of the things that's going on in the world of open source.
Teamwork.
Yay. Teamwork makes the dream work. Okay. Next up, John. I know you have a light up musical instrument.
I have a light up sousaphone.
You're back.
Oh yeah, this is fun.
Thank you for coming back. I sent this to someone who makes these, and they're like, "This is cool."
Yeah.
Okay.
So this is a sousaphone. I hope you can still hear me. I'm kind of far away from the mic.
Oh yeah.
But covered with Neopixel strips, and I've got a little control box back here that I'll show you. The interesting thing about this particular project is the programming behind it, because I'm a software guy, not a hardware guy. So what I did was, well, that's not interesting. There's an interesting one. What I did is I have all these pixels mapped out in both polar and rectangular coordinates, so that so that I run almost like a shader program over them to make all the designs. And so all the designs are actually really efficient, really fast, using the libraries from the Fast LED library. And as well as working pretty well. It's powered by a big, gigantic lithium iron phosphate battery. But I'll try to show you the control box back here. Let's see if I can get this one-handed. Okay, so back here is a 3D printed control box. It may be a little hard to see, but depending on...
Clouds.
Yeah, that would be clouds.
Clouds.
I can change the different, these are all the different patterns I have. And then over here, I have different colors and color schemes I can change it to.
USA.
And these are, the USA one is apt for what's coming up soon, 4th of July. And so I can change the color to, let's see if we can see the red, white, and blue there now.
Yeah.
And then I've got a very important switch back here. This switch turns on the glitter, so now it sparkles.
That's cool.
This is amazing.
And the nice thing about it is, like I said, the software is the more complicated part, though. This does have crazy power distribution because I want it to be as bright as possible, so I can drive these at the full almost 8 amps, 9 amps that it takes to drive all these. But it also works for smaller projects like this hat, so the same code is running on both the hat and the tuba. And I can switch.
Cool. You can make things that match your musical instruments.
Yep. So my wife wears this when she's walking next to me in the parades.
Okay.
Yeah.
So it's clear I'm with this guy.
Exactly.
He's like, no, we're like a team. Yeah, okay.
I'm with Blinky.
I'm with Blinky.
And inside there is a Trinket Pro. It's actually got a microphone in there too, so it can react to sounds. When I play it, it gets brighter, as well as a few other fun things. But yeah.
All right,
Nice work
John.
with it.
Well, email support@adafruit.com. You get as seen on the show and tell sticker. And if you're interested in redoing this project or building another one, we'll fund it if you want with all the Adafruit parts.
Okay.
And in exchange for perhaps maybe like a learning guide or even like just a ton of photos and something like a blog post if it's not something
I'd
that
love
you
to.
build. Okay.
Here's the thing: any guy who has a sousaphone usually has two sousaphones.
Well, you want
you want backup.
But I have one more bell sitting upstairs.
I knew you did. And you want more people to do this. So when you email support@adafruit.com, ask them to forward it to Phil. And
Sure.
and we'll chat offline, as they say, but it's online really. So
He's a line.
All
all right. Thank you so much. And thank you
Thank
for
you.
bringing music and light to sometimes a dark world. All right.
Love it. So I call it a tuba. It's a sousaphone. I didn't know.
Is it okay to say tuba?
It's okay. It's a marching tuba, but the actual instrument name is a sousaphone. But
Yeah.
any tuba player can play it.
Okay. Maybe we can make people associate sousaphones with like LEDs and they'll be like, no, I want a sousaphone because it lights up.
It lights up. Yeah.
Yes.
All right. Next up, Brian. Hello, Brian. Unmute your mic and show us your project.
Hey, how's it going, guys?
Hey, Brian.
Yeah, so I have also using Neopixels, not nearly as bright as John's though. I'm just going to switch my camera. Can you see that okay?
Yeah, it's like a map.
Yeah, so it's a printout from Google Maps, and you can see that there's Neopixels along it. And what it is it's a map that kind of represents from where I work to where like some of my friends live. So it's like a present for them. And so what it does is it goes to the Google Maps API and like checks the traffic on the 3 different routes home. So let me just light that up. So yeah, it's booting up at the moment. So this is the first route. There's another route up the top and then the route down the bottom. It's nearly 1:45 in Ireland, so there's not much traffic at the moment. So yeah, it's pretty certain going to get A all the time. But yeah, so the number represents the amount of minutes that the journey's taken at the moment, and just because it was a clock 7 segment, I decided to just throw in the time kind of in between. So every 2 minutes it will go back and check the travel time for those 3 routes, and whichever one's fastest, it will light that one up. And if it also compares the travel time against the normal travel time, so if it's slightly slower, it'll turn the Neopixels yellow, and if it's a lot slower, it'll turn them red.
This is so useful.
This is like the most useful thing.
This is so useful.
What are you using to try? Is it a Raspberry Pi? What's running it?
No, I'm using an ESP8266. So I don't know if you can see it. It's a bit dark. I can probably turn up the light a bit. The other way.
This is so useful.
Yeah. So yeah, it's just an ESP8266 and like a couple of capacitors for the smoothing of the power rail, and then the 7-segment display, and everything else is running directly on the ESP.
This is great. You made this for your friends?
I did, yeah.
You're a good friend.
Yeah, they better appreciate it.
Yeah. So email support@adafruit.com. You get a seen on show and tell sticker. And here's the thing: if you want to build another one, we'll fund the gear for this, and maybe if you want to do a guide.
Yeah, this is so cool.
For more people to make different versions.
I didn't know
of
you
these.
could do this with an ESP. I'm surprised. I mean, it's awesome,
So
but it's
just
that's
have
pretty
them.
intense.
If you're interested in that, just put a note. Forward this to Phil after you get your sticker.
Yeah, I actually have been taking photos of when I was building it. I was gonna like I'm in the middle of putting it up on Instructables, but like yeah, I'd definitely be interested.
Okay.
In
Yeah,
doing
free
the same.
gear.
And just one thing: if one of your friends does something really terrible, you can mess them up, and when they look at it, it'll make them go in.
Yeah, just if anybody is interested, like I wrote a library for the integration with the Google Maps stuff. So like if you just search in the Arduino library manager for Google Maps, I think it's the only one.
Okay.
So
Right
there's
on.
examples there of how to use it too.
Okay.
Right.
All
Nice
right.
work,
Well, thank
Ryan.
you so much. We're going to go to Rebecca, but playing us out, John, if you can get your tuba ready and play a little bit at the very end. Sousaphone. I know. We just even talked about that. I'll edit this in post. Wait, this is live. Okay, Rebecca,
Hey, Rebecca.
show us your project, and then John will play us out with a couple
Sousaphones.
Sousaphone tunes. Hey, Rebecca.
Hey, Rebecca.
Hey, Rebecca.
Hello.
Hi guys.
Oh, hey.
Hello.
How you doing?
Hi.
Hi. I think you have some internet delay.
Good. Tried an Arduino.
Yeah.
I do.
Yeah, me too. Oh, I think you're. Yeah, I think you. Do you want to just hold up your project?
Can you guys hear me?
You're cutting out.
Yeah, I think you're delayed by like 20 seconds, which is kind of funny.
We could tell you about the future. Nothing's really happened in 20 seconds.
There's more Sousaphone in the future.
Yeah. Well, how about you come back next week? You want to do that?
If you can get Ethernet, that's always best.
I think we're going to do that.
Wi-Fi is.
Yep. Yeah, she can hear us. Okay.
Okay.
All right. So, John, play us out.
Sousa.
Here we go.
All right. Can I make a request?
Yes.
Can I make a song request? You know when they were talking to the aliens in Close Encounters of the Third Kind, and they're going back and forth? It's like do 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 do. Yes, that was on my list of things to do today. Excellent. I'm so glad I crossed that off.
All right. Thanks, everybody.
All right. Thank you so much.
Magical show and tell.
Thank you, Tony. Thank you, Rebecca. See you next week. Thank you, Orlando. Thank you, Pedro. Thank you, John. Thank you, John. Thank you, Brian. Everyone gets like reports. Thank you so much if you're on the show and tell. Email support@adafruit.com, and we'll send you a sticker. We'll see you on Ask an Engineer. What did Chuck Woolery do? He's like 2 and 2.
I don't know.
Nah, I'm old. Okay, bye. See you soon.